Hello! In this module we will discuss two very fundamental questions of software testing. Namely, what is software testing and why do we test? We will also take a look at some definitions that have been used over the years. Before we go, I would like you to take a few minutes and write down your own answers to these questions. Try to form your own definitions of what software testing really is and why we do it. Come on, don't just sit there, think about it. Thank you. As you will see, there are quite a few definitions proposed in the past, all with their own slightly different meaning and focus. Take Dr. Bill Hetzel, for example. He was one of the pioneers of software testing. Already in 1973, he stated that testing is the process of establishing confidence in that a program or system does what it's supposed to do. So, Bill's early definition seems to be mainly concerned with showing that the program works with respect to its intended functionality. But what about non-functional requirements, such as response times and memory consumptions? Well, later in 1990, the IEEE standard on software engineering terminology stated that testing is the process of exercising a system by manual or automatic means to verify that it satisfied specified requirements or to identify the difference between actual and expected results. One difference here is that they add finding faults in the testing definition. And they also opens up for more non-functional testing by specifically talking about meeting specified requirements rather than the more fluffy do whatever it's supposed to do. Paul and Vendal's definition from a book in 1995 is almost overlapping. Testing is a process of planning, preparation and execution to establish the characteristic of a software product and to determine the difference between the actual and requirement status. But as you can see, these guys are more process-oriented than the others. Note that they talk about planning and preparation in addition to the execution of the test cases. They also think that we will learn from the test how the system actually behaves. Okay, that was a lot of definitions, but please bear with me, just one more tiny little definition left. The last definition I would like to talk about is the British standard from 1998 stating that testing is the process of exercising software to verify that it satisfies the specified requirements and to detect errors. So this standard further emphasizes the focus on finding faults by revealing errors. Now these are 4 definitions, but they are also partially overlapping. Pause the video for a moment and try to relate your own definitions to these. Were you right? Were they right? Were anyone more right than another? Are you more concerned with proving that your software works, or do you want to find bugs? Okay, welcome back. If you took a nap instead of thinking, please pause the video again and do your homework. Anyway, a guy called Boris Beizer, another software testing pioneer, created a model that pretty much addresses these different attitudes towards software testing. He calls it the maturity model, and it has 5 levels that tries to capture the maturity of testing activities in a certain organization. In Beizer's model, the level of maturity is pretty much dependent on the purpose of your testing. As usual, we throw ourselves right into the subject and look at the lowest level of maturity. At level 0, the purpose of testing is to show that the software doesn't work. At this level, there's no difference between testing and debugging, and it basically means the same thing. The upside, though, is that there's no minus levels, so we go straight on to level 1. At level 1, the purpose of testing is to show that the software works, rather than just debugging apparent problems. Continuing to level 2, it says that the purpose of testing is to see that it doesn't work, in contrast to level 1, where we want to show that it works. So this is less of a confirmatory activity, more trying to show that there are bugs in the software. Level 3 states that the purpose of testing is not to prove anything specific, but reduce the risk of using software. And level 4, which is the highest level, states that the testing is a mental discipline that helps all IT professionals to develop high-quality software. Here, Beizer wants to emphasize that testing is not something that is done exclusively by testers. It's something that should be at the highest level of maturity in the minds of all your software engineering personnel in the company. Finally, I would like to state a quote by Edgar Dijkstra, a famous Dutch computer scientist in program testing. He was stating that program testing can be used to show the presence of bugs, but never to show their absence. Meaning that there's no way for practical cases to prove that a piece of software or system or program is bug-free by using testing. We will examine this further in a future video. But before ending this video, let's summarize these views on software testing into some whats and whys. The what thing that we notice is that testing seems to involve execution of the software. Having executed the software, you may come to a verdict by checking the observed outcome against the expected outcome. This verdict can be either pass or fail, based on the comparison of these outcomes. Of course, this relies on that you have an observable output from your software. So if you're not executing the software, you're not, in this definition, doing any testing. This would mean that reviews, for example, would not be considered testing. If you look at the whys, the first thing we see is that we typically test with the intent of evaluating whether the software meets its specification or intended use. Another intent could be to measure some non-functional aspects, such as robustness, performance, usability, or something else. And last but not least, you're testing to detect existence of defects. So one could really say there's no single overarching objective in software testing. And this concludes the whys and whats of software testing.